Hello, we're going to be looking at parabolas in vertex form. This is a way of taking our function f of x or y is equal to x squared and shifting that parabola to the right or left, up or down, and stretching it or compressing it vertically. Our main graph looks like f of x is equal to a times the quantity x minus h squared plus k. The a out in front essentially multiplies every y value by that number. So it will horizontally or vertically stretch or compress the graph. The h inside is going to move the function left or right. If the h is positive, x minus h will move it right. If the h is negative, x plus h will actually move it to the left. That's counterintuitive. The plus k outside change is an add-on. If k is positive, that's going to move the graph up. If k is negative, it moves the graph down. So in general, if we're given the function f of x is equal to a times the quantity x minus h squared plus k, this graph has been shifted k units to the right or h units to the right and k units up, and the vertex will occur at h comma k. When a is positive, the parabola will open upward, and that will make the vertex a minimum. When a is negative, that parabola will be flipped across the x-axis, and the parabola will open downward, and that vertex will be a maximum. If we want to find the x-intercepts of the parabola, we can just go ahead and set y equal to 0. So we let f of x or y equal 0 in this quadratic equation, and we solve for the x values. To find the y-intercepts, we just let x equal 0. And here, we're going to solve for the y value. Okay, let's look at an example or two in this Match My Parabola experiment. We're going to go ahead and plot the basic parabola through these points. Y or f of x is equal to x squared. And we have it. That is our very basic parabola. Challenge 2 talks about moving this parabola. If I wanted to plot that blue graph, it's essentially moved everything up 1, 2, 3. I might think of y or f of x is equal to that x squared plus 3 outside change. The green graph is moved 4 to the right. So in this case, it's going to be an inside change, but it's counterintuitive, so moving right 4 actually subtracts 4 inside. Let's check my work here, and I'll leave you to think about the orange and the purple. Oh, it looks good. Another thing we can do is check out where we have a vertex and then extra points in the graph. Here, we're going to exploit that f of x is equal to a times x minus h squared plus k. Let's go ahead and plot the vertex. So let's plot this in vertex form. That would be f of x or y is equal to x minus 4 squared minus 2. Note, that's the vertex because we've moved it to the right 4, counterintuitive inside change, and down 2, that's an intuitive outside change. Let's see what we get. Hey, that's not bad. It does go through the vertex, but it doesn't hit these other 2 points. What we're going to have to do is we're going to have to figure out what that stretch A is. So going back here, we found the H and the K and plugged those in. We just need to figure out what that stretch is. To find that, I can actually use any other point here. I'm going to go ahead and use the point 0, 6. We know that 0, 6 is on the graph, so we can actually plug that in for my y and x values. Y is an f of x. So if I have f of x or y is equal to a times x minus 4 squared minus 2, and I plug in that 0.06, I will have 6 for y is equal to a times 0 minus 4 squared minus 2. I will have 6 is equal to a times negative 4 squared, which is 16, minus 2. I'll go ahead and add 2 to both sides. And that will give me 8 is equal to 16a plus 0. And now if I divide by 16, I'll solve for a. That will give me a is equal to 8 over 16, or 1/2. If I go back and plug that 1/2 in for my a function here, what that says is it's taken that original parabola and it has compressed it by a factor of 2, or 1/2. So we should find that this graph will be a little bit flatter than the original one. Let's take a look. Aha, it does go through those points. Hopefully this has helped you a little bit with finding a parabola in the vertex form. Remember, our function is equal to a times x minus h, the quantity squared, plus k, where h and k are the vertex, and a is that stretch or compression. If a is negative, it will actually flip this graph about the x-axis. If a is greater than 1, it will stretch it out. If a is between 0 and 1, it'll compress it, as in this case, compressing it vertically. Okay, I hope this has helped. Thank you.